Hello dear friends, myself Anvisha Ghosh and I am back in my YouTube channel with a totally different kind of new video of mine, and this video I am going to post mainly for my beloved students. So now Anvisha Ghosh has come as the role of Anvisha ma'am, and our today's content will be on easy learning with fun. So, my dear students, hope you are all fine. Today, my teaching video is based on my ICSE Class 9 students and on the subject of chemistry. And what is the chapter? The 7th chapter of your chemistry book, that is Study of Gas Laws. So, let's start this chapter. So, before entering into the main part of this chapter, let's introduce this chapter by understanding the definition and some general properties of gaseous substances or simply gases. So, what are gases? Look, a gaseous substance or a gas must have these following properties. Gas, and their various properties have like no fixed shape, gases have no fixed shape unlike you and me, no fixed volume also, but while you will solve the various numerical problems regarding gases, you will find the term volume of gas and its unit. Gases have no own volume, but while it will be placed in a container, it will attain the volume of that particular container. Okay? Third one is the attraction between the different molecules of gases, which are also called as intermolecular attraction, is very low than that of the other two states of substances. These are solid and liquid. Okay, so intermolecular attraction very low, and this results into such a condition that within a container the gas molecules spread throughout all the spaces. Okay, that means the gaseous substances spread very easily and the molecules are moving randomly. So the molecules of gas move randomly throughout a large space. The fifth one is fast diffusion rate. Fast diffusion rate. question is must coming into your mind that what is diffusion? You may have slight idea in your previous classes. So the appropriate definition of the diffusion is a physical property of substance where molecules of that substance move from the higher density region or higher concentration region to the lower one. For example, if we burn an agarbatti, then after some times we can look, just after a few seconds we can look at the smoke of that burning agarbatti spreading throughout the room or throughout our surrounding or nearby places. And sweet smell we can feel. Those persons who are there surrounding that agarbatti just feel the smell after some times. So it is a property, it is a physical property of substances called diffusion. And gases also show diffusion, but the diffusion rate of gases are very fast. But one thing we must have to know that if the two gases react with each other chemically, then the diffusion will not be applicable. So the process of diffusion will be applicable for those substances or in particular a substance which can't react with its surrounding. Okay? And some other properties also there. It is a general property of gases, and based on these properties, we or the scientists feel the courage to analyze all the properties by applying the kinetic energy rule, the thermodynamics rule, and chemical rules. Okay. So after that, we can proceed into some gas laws, and based on these laws are the main chapter study of gas laws comprised of. So it is a basic introduction of gas before starting the gas laws. Now we will be going to discuss about an activity which demonstrate about these physical properties of gases by using a syringe and putting piston or rubber cork, etc. So let's see that experiment. Now it's activity time. I'm very sorry to say that at present I don't have the practical equipments of this experiment to carry out. So sorry, students. In near future I will definitely arrange these items, but nowadays all things are being virtual, so why not it is applicable in studying chemistry. So definitely we are trying to do best to gift the best thing just for you. just enjoy this class. It's activity time. First of all, see the picture. Here, 3 different syringes measuring 100 ml are there, and at the upper end of each and every syringe has a piston. First of all, we have to remove the pistons from all the 3 syringes. Then, in the first piston, that is this piston, is filled by chalk powder, and chalk powder is of which physical state? Yes, solid. Okay. Then the second, the middlemost syringe is to be filled with water, and we all know that water is a liquid substance. Then the third syringe will be filled by air, which is a gaseous substance. Then all the 3 syringes, after removing the pistons, are placed by putting a rubber cord in each of them in the mouth of the piston. And finally, the piston will be replaced and some pushing force is to be generated. It is the main procedure of this experiment. Now, what will be the result? The result is, in the case of first piston, we have to apply the most greater pushing force. In case of pushing the first syringe with the help of piston, the applying pushing force is the greatest, because within that chalk powder is there, and chalk powder is solid, and solid substance has the molecules which have the greatest intermolecular forces. That's why they are very compact, and to push any solid substance, a greater pushing energy must be applied. In case of the second piston, as because water, a liquid substance, has been kept, so the pushing energy is definitely greater but lower than solid. In that of the chalk powder filled syringe. But is it be lower than the case of the third piston, the third syringe? No. In the third case, the third syringe that is filled with air, a lower pushing force is enough, because air is a gaseous substance, and as we have already discussed that the intermolecular forces within a gas are very low. That's why the gaseous molecules already move randomly. So in order to move the air molecules, very low pushing energy is adequate. So by considering the pushing energy in terms of pushing energy, in case of third syringe, it will be the lowest. In case of the first syringe, it will be highest or greatest, and in case of the second one, it will be intermediate. And a brief recapitulation of today's class. The various properties of gas has been summarized by this picture. For example, we have taken water vapor, which is a gas. It has various properties like, already I have discussed, like random motion of particles, negligible intermolecular forces, no fixed volume, highly compressible. If we press the gaseous molecules, it will be very easy to make them compressed. Okay, exert pressure on the walls of the container. They can move randomly throughout the container, so they must exert pressure on the walls of the container. Particles move with high speed in a surrounding. The air molecules which are moving, we can feel. They can move very high, with very high speeds. No fixed shape. Lowest density among solids, liquids and gases. Density means the ratio of mass and volume. Mass by volume is equal to density. Small d denotes density. If small d denotes density, small m denotes mass and capital V denotes volume, then d is equal to m by v, and this density value is lowest in gas among the solids and liquids. In terms of density, solid has the greatest density, liquid has intermediate one, and gas has lowest density. Gaseous molecules occupy entire space of the container, and lastly high rates of diffusion. So dear students, these are it is the general introductory class of your 7th chapter, that is study of gas laws. Thus we have finished the general introduction of this chapter, and thereafter these are the different topics. This chapter includes some gas laws like Boyle's law, Charles' law, Graham's diffusion law, and then some other derivative laws or equations like ideal or universal gas equation and the partial equation of gases, and so on and so on. Then some numerical problems must be solved by us based on these laws and equations, and at last practical implementation in this chapter. So in the second class we will going to discuss about Boyle's law. Hope you all have understood, and if you have any queries, then just feel free to ask me over the comment box, and please give me your valuable feedbacks. Bye bye. Take care.